some physicists, even in this room, have been talking about crisis of physics, and recently, because what they expected didn't happen. For instance, supersymmetry. But you know, crisis of physics is like a big defeat in a battle, in a war. The French talk about the big defeat of Waterloo. But the other side of the channel is not a big defeat to Waterloo, right? So, crisis of somebody is it's good news for somebody else. So when supersymmetry was not found, my part of the community was just jumping around. Yeah. It's a little bit more than that, because for many people, the next frontier of physics should be a grand the theory of everything. I think that the theory of everything is a bad idea. We don't know what's out there. There's so much more about the universe which we don't know. I don't think it's a good idea. It's a good scientific program to write the final theory of everything. We should solve the problems one by one, like Faraday was doing, or Maxwell or Einstein. We don't have a quantum theory of gravity. We should find a quantum theory of gravity, because we don't know what happens when gravity becomes quantum. That's a concrete problem. So let's solve that. Let's put together quantum mechanics with general relativity. It's complicated enough because it's a quantum property of space-time. It's changing the way we think about reality. I think we're in a spectacularly good, positive moment in the history of physics. What we have learned about the universe, black hole, gravitational waves, about gravity and cosmology is wonderful. Science is going very, very well. It's not in a crisis, not at all. It's a crisis for those who ask the wrong questions. I think trying to figure out the quantum property of gravity and what happened to a black hole, what happened in the early universe, these are the right question we should address. I said one possibility is to work out all the cosmology and maybe convince ourselves. We're not convinced at all. It's one possibility that this dark matter is, in fact, this white hole. The other possibility is to make an actual detection. So could we see one of them? Well, let's see. Imagine this is really dark matter. We can compute how many they are, because we know how many dark matter are. The astronomers know exactly how much dark matter there is. There's more dark matter than matter. Sort of few times more in a galaxy, okay? So the density should be comparable, a bit higher, but dark matter is more diffused. So we can compute how many there are. We know the weight of these little things. I just told you, a fraction of micrograph, so we know how many there are. And so it's a simple calculation to see how many of these little things there are. And the result is that presumably in a room like this one, every once in a while, I mean, one goes by. Okay, so maybe there is no one just going by with this. We couldn't see it. We couldn't touch it. The only interaction would be gravitational, the pull. So if we had something extremely sensitive, okay, imagine we build a machine, a detector, where something goes by, so intuitively, a little pendulum, something goes by, well, start pendulum. Okay, now pendulum mechanics is complicated, but maybe something electronic, something quantum electronic that could detect that's one of the things I'm doing right now. I'm trying to figure out what's the best chance we have to build a detector that could detect one thing's flying by. Is this going to happen? I don't know. I'm working on that. But I know that when I became a faculty at Pittsburgh in the 1990, and my friends were saying, we're going to build a gravitational wave detector, that seemed really crazy. And they did it, and they got a Nobel Prize. So, you know, it doesn't mean that all project is going to work. Many projects don't work, but some do work. So in principle, yes, it's all possible to detect. In principle, it's possible to detect one of these things. So in principle, it's clearly possible to detect them. Practice building a machine, and they're, as I said, one particle flying by every once in a while. There's not a lot of them, so it's not easy to detect. Now let me go toward the conclusion. I've asked you to follow me inside the black hole. all the way to the center, in a sort of land we know, strange but known, through the jump, hypothetical, land we don't know, and then out of the white hole, and then we're back to the stars, like say Dante, ritornammo a rivedere le stelle. We came back to see back the stars. What is this? This is mind traveling, right? It's traveling with the mind. And it's what Dante does. Dante takes us to this incredible trip into hell, purgatory, paradise, through all the forms of morality, through all the stage of human psyche and mind. Beautiful. But I think is also what science does, what the best science does, the best theoretical science. Science is made of all sorts of things. There are mathematicians, very good equations. There are the people who do experiment. There are people who find out experiment. But then there are the people who think the new, like Faraday, who invented the fields, which just created something completely new. And how do you do that? You mind travel. Think for a moment. Let me give you just a few examples in my last minutes. Anaximander, which is one of my great passions, great thinker in the 26th century ago, who figured out that Earth is like a stone floating in the nothing, right? Before, people thought that the sky is above us. He understood that the sky is all around us, and Earth is just a thing like there. How did he do that? He mind traveled outside it. He saw it from the outside. In fact, he, same Anaximander, is credited in antiquity to be the one who invented the geographical maps, which is funny, you know, because people have been traveling and trading and traveling long distance for centuries, millennia. Nobody thought of take a piece of paper, writing a map. Why? Because it needs to be creative to change perspective, to imagine what is a map. A map is how the land would look seen from an eagle, super, super high. But take imagination to think you're an eagle and you're up there, or to think you're, like, you know, just like the astronauts on the moon looking at the Earth from somewhere. He did that. So he was capable of mind traveling. Hipparchus, the greatest astronomer of antiquity, has a calculation of the distance of the moon, which is it's a subtle geometrical argument, very, very beautiful. But it starts by saying, imagine the Earth, there's a sun there, and there's a shadow of the Earth, there's a cone, and imagine to go to the tip of the shadow of the cone of the Earth and look back. And then there's a geometrical arc, the angle you would see. I mean, I have not time to go into that. So again, he's mind traveling to the interplanetary space. This is 2 millennia ago, thinking how would sun and earth and moon would look from the tip of the space. And Copernicus imagined the solar system seen from the sun. Right? That's what he did. Change perspective on the solar system. And Kepler has this fantastic book. It was published. He wrote his book all through his life. It's called The Dream, the title, and was published after his death, in which he tells the story that he and his mother are taken by a demon to the moon. And then he goes to the moon and describes the moon and describes how the solar system looks from the moon. So what the hell is he doing? Well, he's doing something fantastic. He's taking out a different perspective and see how Venus and the Earth looks from a moving body, the moon, to convince us that what we see on Earth is nothing else than something seen from a moving body. So it's an argument it's a profoundly rhetorical, powerful argument for Copernicanism, based on changing perspective. Because when you change perspective, what is it? I mean, who cares how the solar system looks from the moon? That's not the point. When you change perspective, you realize that your own perspective is partial. That's the point about changing perspective. It's in science, like in politics, like in economy, like in everything. You put yourself in other shoes somewhere else, so you realize that what you usually think might be wrong, because you have a different point of view. And so on. I mean, Einstein famously traveled talked about traveling on a ray of light, riding a ray of light, or falling in an elevator. Maxwell also had a demon, right? Maxwell thought of being small like a molecule, And this demon seeing the individual molecules, what Maxwell demon is called, opening, closing the door, letting the molecules go, in his work, not on electromagnetics, his work on the kinetic theory of gas, on thermodynamics. But how do we mind travel? How do we know what's going to see from a different perspective? I think that the answer is to stay on a subtle balance between what we keep with us, the Einstein equation that tell us up to there. What we keep with us is the knowledge that tell us something, and what we leave home. Because to make a step ahead, we have to leave home something, right? Einstein leaves home simultaneity. Kepler leaves home the circles. Copernicus leaves home the idea that the Earth is the center of the universe. We left home the idea that you can always describe things in space and time, something basic, okay? How do you know what to bring yourself and what you leave home? That's, I think, there's no method in science. There's no recipe for that. Science is just trial and error. You keep walking on the boundary of what we know. We know quantum mechanics. We know general relativity. We know what happens to black hole up to there, and you keep turning things around until you find the little hole that allows you to put together the puzzle in a different manner, in such a way that it makes sense, and there's a possible step ahead. And then, experiment tell you whether it is right or wrong. So I think this mind traveling is science at its better, and I think that science is imagination, besides just being calculation and numbers. And in this, science is very similar to Dante, poetical imagination, and to the rest of our life, which is a life of emotion, of imagination. And I think this part of science is always, is often forgotten. Science has an image of coldness, but this is science, I think.